Hey everybody, Mr. D here. In this one, we're going to be talking about interval notation and then domain and range. Remember, domain is our input, range is our output, aka x values, y values. Good news, this video should be relatively short because a lot of the answers are provided. How fun! So, without further ado, let's get going into some basic vocab. You know the drill. If you have to pause it, please do. If this makes good enough sense where you can just kind of jot down some quick notes, then hey, even better. All right. First, interval notation. This is how we represent solution sets. So a solution set is when there's like a whole bunch of numbers. So if I wanted to say everything between 3 and 17, I could just say everything between 3 and 17 instead of listing out 3, 4, 5, 6, 7, blah, 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 blah. Now, when we do this, it's important to keep track of whether we're using parentheses or brackets, because parentheses indicate that an endpoint is not included. So everything up to a certain value, but not including that value. Brackets, and brackets are kind of like squared off parentheses. Brackets indicate that that endpoint is included. Now this last bullet point is pretty gosh darn important. Parentheses are always used with infinity and negative infinity. The reason for that is infinity is not a number. Infinity is an idea. It's a concept. So you can never actually equal infinity. You can only approach it infinitely closely. Mind-blowing, I know. So, let's deal with some intervals here, shall we? This first example, we have everything from -4 up to a +3. The -4 has an end point. It's filled in, therefore it's included, but the 3 does not. So that means 2.9 is included, 2.95, 2.96, but not 3. So I need to use a bracket on the -4, comma, a parenthesis on the 3. Second example, I'm going from -1 to a +5. -1 is not included, so it gets parenthesis. 5 is, so it gets a bracket. All right, next one. We have -2, comma, oh boy, well, it goes onto the arrow. That means it's going to go this way forever. Well, if I continued going this way, I would be approaching infinity. So that's going to be positive infinity, which by default gets a parenthesis. The -2 is filled in, so it gets a bracket. If you ever see an arrow, by the way, if it's going to the right, it will always be a positive infinity because numbers are getting infinitely large. If it goes to the left, it would be negative infinity because numbers are getting infinitely smaller or lesser or more negative. That being said, next one. I'm going from negative infinity to a +1. Negative infinity has to have parentheses, and the 1 does not have a filled-in circle. Next one. Ooh, we have two separate pieces. Shnikes. So I'll have negative infinity to -2. -2 gets a bracket. And then I have 1 to positive infinity. Because remember, negative infinities are always on the left, positive infinities always on the right. But now I need to say, how do I represent both of these? Well, there's a mathematical symbol. Looks like a giant capital U. That is the union operation. So that means this and this. All right. Last example here. We would have negative infinity. Oh, that is a gross infinity. I'm so sorry you had to witness that, people. Let me redo that. Negative infinity. Yeah, not great, but better. And 4 to positive infinity. Okay. Now, graphically, how can we do this? Graphically, when we're dealing with domain and range, we have to keep in mind that our domain represents the x values and our range represents the y's. So for our domain, we're going to kind of follow along on the x-axis and see where our graph is defined. And for the range, we'd follow along on the y-axis. A lot of times for these, it helps to denote what is the leftmost and rightmost value. That's what these little dotted lines are for. And then what are the lowest and highest points. So that's what those or horizontal lines are. Just like before, if something is included, we're going to use parentheses if it's not included. Or sorry, we're going to use a bracket. If it's not included, we'll use parentheses. And an arrow indicates that something goes on forever. A lot of times that's going to indicate an infinity of sorts. So let's see an example of a graph. So if I'm talking domain, domain is only the x values, right? So what I want to kind of think about is if I were to put my function here kind of in a box, the domain is going to be the leftmost and the rightmost values of that. So the domain here is going to be -3 to +2, because -3 is the furthest left it went, and +2 is the furthest right. Since I'm seeing a closed-in circle here and here, those will actually both get brackets. Fun. All right, so now, if I did that same concept, but now I'm dealing with the range, or the y values, the highest value, or sorry, the lowest I should start with, lowest is down here, and the highest value is going to be up here. So it goes down here from -5 up to +5, so my range would be, I already jumped the gun. Our range would be -5 with a bracket to +5. Why am I just getting so parenthesis happy? What is going on, folks? Oh boy. There we go. All right. Next one. I want to figure out the furthest left and furthest right. So left to right, that's going to be my domain. It looks like this is the leftmost value, so -6. And this is the furthest right, so 0. Our domain is going from -6 to 0. -6 was not included, 0 was. My range is going to go from lowest to highest. Well, the lowest value is here at -3, included. The highest was up here at +4. It's got an open circle. So we're going to go -3 to +4. So that's how we interpret these. All right, so now the rest of these graphs, you guys will actually have access to this with the PDF that's going to be posted to our course schedule, which you can get through Google Classroom. So you guys will have access to all of these other graphs, but it's going to follow a very, very similar approach as we go through. All right? You're always looking for the furthest left and furthest right for your domain, and then the furthest down, furthest up, or the lowest and highest for the range. Okay? So you'll have access to all of these individual graphs, and you'll see what the domain and ranges that correspond should be. All right, so now let's kind of go backwards from a funky looking graph. All right, this graph we're going to learn later down the road is actually what's called a piecewise function. I'm noticing it's got an arrow on the left, so it goes forever to the left, and this arrow on the right side is going kind of diagonally, so it goes forever up and forever right. So my domain should be pretty straightforward. It's going to be negative to positive infinity. Yay. Again, sorry for the junky infinities. Next up, my range is going to be the lowest to the highest. Well, my lowest value that I hit is right here at -4. The highest, well, hey, that's got an arrow, so that's going up forever. So it's going to be -4 to positive infinity. Positive infinity is going to get a parenthesis, because it's infinity, you have to. But -4 gets a bracket because we actually obtained that value of -4. We actually reached that. Part C is name the x-intercepts. Well, x-intercepts are any point that it hits the x-axis. It looks like right here at 1 and 7. So I like to write these as coordinates, 1, 0, and then 7, 0. Please keep in mind on Math Excel, when you guys are entering these, a lot of times you're going to have to write as just 1 and then 7. For whatever reason, Math Excel does not like the ordered pairs, whatever. Name the y-intercept. Y-intercept is wherever it hits the y-axis. So right here at 0, 4. Then it's going to say, what is f of negative 3? All right, so f of negative 3, that says my x value is negative 3. What's the y value? So negative 3, comma, what is what's happening here? Well, if x is negative 3, the y value paired up with that is going to be 4. So f of negative 3 is going to equal 4. And then find the value of x for which f of x, aka y, is negative 2. Find the value of x for which f of x is negative 2. So that means we don't know the x value, but we know the y value should be negative 2. So if I know y is negative 2, I can look over here. So when is y negative 2? It's right here at 2, negative 2. Also here at 6, negative 2. So it actually happens 2 separate times. 2 and 6. So we're going to have the x values of 2 and 6 because we have those points of 2, negative 2 and 6, negative 2. Again, when you enter these in on Math Excel, chances are you're just going to have to type the individual x values. It doesn't want those full-blown coordinates. All right, last and final example coming at you. Oh, I lied. Oh boy, did I lie. Second to last example coming at you. All right. Yeah, you know what? Actually, we can... Ooh. You know what? We'll just do this one here. You guys will have access to this filled out in the notes. But if you can follow along with this one should be a piece of cake. So we'll just do one more. And now I'm not a liar. Yay. All right, domain is the x values. Furthest left is going to be negative infinity because it goes down and left forever. Furthest right is going to be 3. So negative infinity to a positive 3. And it actually hits the 3 value, so it gets a bracket. The range, the lowest value, negative infinity because it's going down forever. The highest value is right here at 4, so negative infinity to positive 4. Ooh, and that should be a square bracket because it actually reaches the 4. I don't know what's going on with my negative infinity drawing skills today, but they are horrendous. All right, next one, f of 0. What is it? So that's asking, if x is 0, what's your y value? Well, hey, isn't that just the y-intercept? Right, 0, comma, in this case, 3. So 0, 3. Ooh, bonus. We got a 2 for this little buy one, get one there. Next up, x-intercepts. Right here at negative 3 and here at positive 3. So I'd have negative 3, 0 and positive 3, 0. The values of x for which f of x is less than or equal to 0. Okay, so this one's going to be kind of funky. All right, f of x less than or equal to 0. Remember, your f of x is really like a y. So when are your y values less than or equal to 0? AKA, when are they negative? Well, if y is negative, that means it's going to be below the x-axis. So what graph points would satisfy that? And that's going to be everything on that green highlighted chunk. Because as soon as my graph goes up here, it's going to be back up in positiveville. Since it's less than or equal to 0, I can actually include this guy right here as well, since that's equal to 0. It's on the axis. So for what values of x? Well, I'd have negative infinity all the way up to negative 3, and then just 3. So negative infinity to negative 3 and just 3. And lastly, the value for which f of x is 4. So we don't know the x value. We're trying to figure out what x value, that's supposed to be a dotted line box, will give me a y value of 4. If I look at my graph, my y value of 4 happens when x is 1. So the x value that would produce that would be 1. All right. Your last example is going to be the exact same thought process. So if you followed this one should be a cakewalk. You know the drill, folks. If at any point you have questions, please let me know. And as always, good luck, have fun, be safe, roll tide. And don't forget your homeworks in Math Excel.